Okay, just a final question. Can you hear me and can you see me? Okay, perfect. So, yeah, welcome everybody to our first live stream of our ROS Summer School here at the University of Applied Science. Especially I would like to welcome all the viewers at the Kamara Guru College in India. And I also would like to thank at this point the International Network of Knowledge for all the support and the organization. Let me introduce myself maybe first. My name is Heiko Engemann. I'm working as a research assistant at the Lab of Automation and Robotics here at the university. And I did my master also here in mechatronics, and I'm currently working at different research projects which are all related to some kind of mobile robotics. I would also like to introduce Professor Calveit and Professor Verein. Or maybe just introduce yourself.
Yeah, hi there. So it's us. We are allowed here to torture students with mobile autonomous systems, with robotics and automation. And my highly esteemed colleague, Sascha Verein, he's even the world champion in the logistic league recently, RoboCup. And of course, everything is here related to ROS. The nice thing is that we try to make this kind of event now, let's say, publicly available, and that we run it now for the 6th time, and already exported once to South African partner university. And today we have the last day. It's a competition day where all the knowledge can be applied to a small rover, and then it should more or less drive autonomously in the we set up, and I think Alexander will tell you as well a little
about the approach. Also a warm welcome from my side. I hear that you have that will be a great thing. Our participants are very happy to be there. We have the competition right now going on in the other room. I don't know if we over in a minute, so you'll see yourself. And for me it remains to say maybe we see us time soon with the. Yeah. Good, thank you.
Yeah, so we just give it back to Heiko, and I think he will present some contents of the concept of the ROS Summer School, and then we make a live demonstration, or we just switch over to the other room where we have all the robots and the participants, and they're all wearing the same nice T-shirts here, so you will definitely. Yeah, it's quite high.
He's way
quite tall.
He's a tall guy.
Okay, so Heiko will continue, and then perhaps we see us again in India, because we have a nice Indian summer right now. No, it's not.
Okay, thank you very much. So let's go on with the presentation. I will minimize a little bit webcam image. So I hope that the network will stay stable and that I can stream the whole hour. Just if there is any kind of sound issue or stream issue or something like that, just tell me in the chat and I will try to fix it as soon as possible. What will be the presentation about? I will start with a short overview over the Moscow Institute, which is basically the organizer of the ROS Summer School here at the University of Applied Science. Then I will continue with a short introduction into ROS. Not that technical, more about the benefits of using ROS in your robotics applications. And after that, I will talk about the concept of the ROS Summer School here. And then I will switch to the live stream of the competition. Let's start with the overview of the Moscow Institute. I already introduced Professor Verein and Professor Calveit. There are 2 additional professors which are part of the Moscow Institute, Professor Scholl and Professor Starke. All of them have their specific main topic, like in case of Professor Verein, it's artificial intelligence, robotics. Professor Calveit's about automation technologies and robotics. Professor Scholl is focused into image processing and visualization. and Professor Starke is more focused on industrial applications. The research projects of the Mascor Institute can be divided into 3 different fields, which are UGV, ground-based vehicles, then UAV, the aerial vehicle, and also industrial, which is about industrial robots. In addition, we are also competing in a couple of competitions, and our currently biggest competition is MBZIRC. And to fulfill the task of this competition, we have to develop solutions including technologies of all 3 different fields. We'll talk about that later a little bit more in detail. One main feature of the Mascor Institute is that we are loving to use open source. At first, of course, ROS, the robot operating system, it's like a middleware for robotics applications, and till now it's pretty much common to use it in the field of mobile robotics. So there are many research institutes or universities all over the world which are using ROS to develop applications in the field of mobile robotics. In addition, it has also a growing leverage in terms of industrial applications. We are also using OpenCV, well-known image processing and computer vision library. Interesting side note, OpenCV is already implemented in ROS. That's also the case for PCL, the point cloud library, which we are using for all kinds of 3D point cloud processing. So why are we using open source? Basically because of the community. If you have a really great open source project, then you normally have also a growing community. And this leads into a continuous development of the open source project itself. Like, for example, implementing newest algorithms or drivers for hardwares, something like that. It makes the open source project even greater, and then of course the community is also faster growing. So it's like a really dynamic project. I would like to show you now a short video. It's an overview video about the Mascor Institute. It's a little bit outdated, but you can get a nice impression about what we are doing here. So the first example is about simulation. What we're trying to do always is to simulate our algorithms or our codes at first in some kind of environment before we use it on the robots, because that can be quite dangerous or expensive. The next example is a multi-robot system which we use to reconstruct the surface of buildings. So what you can see here is a UGV standing on the ground and localizing in a map, in a 2D map, and the UGV flying above it. And the UGV can localize itself just based on webcam images and the marker which is attached to the back of the UGV. As you can see here on the bottom, that's a 2D map of the backyard of our department. And you can see here these colored lines which reflect the surface of the building. You can even see in the middle there a little tree in this backyard. The next example is a localization approach with quite a high accuracy. It includes a stereo camera and active LEDs. And it was originally planned to use it in the mining industry as some kind of guiding system. The next example is the classic autonomous navigation of a UGV. You can see here a 2D map of the floor before our lab, and we put there some dynamic obstacles in form of boxes in the way or in the path of the UGV, and based on the laser scan data it is able to avoid a collision and to plan a new path around these dynamic obstacles. Also a big part of our summer school here. The next example is a system what can be used for mapping when you don't have any kind of odometry, which is especially the case in the field of UAVs. It's a laser scanner and an IMU, and that's it. What you can do with the system is you can do map, you tilt it and rotate it, you can even reconstruct the environment in 3D. Here you can see the walls and even the lights there, the edge. The next example is also a research project where we mapped a big tunnel. And we did it with the help of a 6D laser scanner from Velodyne. And yeah, these data, they are really interesting in case of simulations for some catastrophic events, for example. The last example is more related to industrial robotics. Here you can see that we are using there an RGBD camera to check the workspace of the robot. And we can put now dynamic obstacles in the workspace of the robot. In this case, they are the arms of the student. And the system is able to plan a path around these dynamic obstacles in order to reach its goal position. Yeah, as you can see, now the robot is like moving under the arms to its goal position. So that's it so far. Let's go on with the presentation. I would like to talk about the MBSIRC challenge because it's really great to be part of it. It's one of the highest in Dove Robotics Challenge. I think the first place will get about $1 million, which is quite a lot. And our team is one of 46 teams which are allowed to participate to the challenge. And we are currently still working on the to fulfill the different tasks. But we have also a couple of results already ready. And I would like to show you a video what we did during the last month. It's kind of a progress video which we submitted to get to the next round, and luckily we were able. We did it. We now part of the next round. So there are 3 challenges which you have to fulfill. First one, every challenge will take place on a playground in the size of a football field. The first one is that you have to land autonomously with a UAV on a moving vehicle. There is a marker placed on the back of the moving vehicle, and it's driving quite fast. It's driving with like 3 meters per second, and so it's not that easy to land on this vehicle. As you can see here, there's again a simulation environment where we test our algorithms, and here you can see that the UAV has now detected the marker. That's why it's green and red. There's another example of real detection of the marker. And in the simulation, it already works quite well to land on the moving vehicle, but as usual, simulation and the real world are always a little bit different. So this is an example where we did it then in real. There's the first prototype which we are using, and also a first iteration, because we are will land quite dynamically because the vehicle is quite fast. We developed some kind of own landing gear. Here you can see an example how it is working. It has some dampers included and also some magnets so that it's sticky, so that it will stick to the marker itself. This is like the first real test with our UAV prototype. You can see on the bottom right the current position of the UAV, which is base link, and the starting position home, and also the marker is detected in the camera image. You can see the camera image on the bottom left. And now it's already able to follow the marker. We'll just speed that a little bit up because the video is quite long. You can see that's already a little far away from its home position. And there it landed. And the next task is then about mobile manipulation. What we have to do there is to find the panel somewhere placed on the playground. And on the panel there are a couple of tools and also a valve. You have to grab the correct tool to turn the valve 360 degrees. Again, everything completely autonomously. You can see some data of our laser scanner in order to find the panel. And this is our completely set up with an industrial robot and a UGV. We also did this in simulation, of course, to test our algorithms first. So that's always the procedure that we do. I'll just skip there also a little bit to see it in the real world. And here you can see how the gripper is like grabbing the tools. By using like a feedback of our image processing algorithm to find the correct tool. Now it will move to the valve and turn it like 360 degrees. There is also another challenge, the challenge 3, which is about grasping objects with a UAV. These kind of objects, they are just placed randomly somewhere on the playground, and what UAV has to do autonomously again, to find these objects, to grab them, to lift them up, and to basically transport them to some kind of special area. That's our prototype for the challenge 3. It also includes a gripper, which is based on a magnet. Our first prototype, but it's already able to move and to grab like these kind of dummy objects which we created. So it lands on the object itself. And due to the magnet, the object will stick to the UAV, and it can, start again and bring it. Okay, that's so far about the MBZirk challenge. I would like to go on now with ROS, because that's why we are here, right? The ROS Summer School. And when we are talking about ROS, we are talking about mobile robots. And mobile robots, they can fulfill various amount of applications, like for example, serving, working, entertaining, rescuing, and so on. For all these different applications, there are 3 basic tasks of a mobile robot, which is locomotion, be able to move on its own, then perception of the environment, for example, to avoid obstacles or to grasp specific objects, and then of course the big part, navigation, which includes localization, mapping, and path planning. Basically, these tasks, they just answer the robot's question, where am I and how to move, where I should do my work. We now take a little deeper look inside that, and we are asking the question, what do we expect from a middleware like ROS in order to fulfill these different tasks like communication, perception, collision avoidance, motion planning? What I would expect is, for me, of course, the most important point, less programming work, then of course simulation capabilities, and so that we can test our code and our algorithms before we use them on the real robots. Then a good community support and low cost. And due to the fact that ROS is a really successful open source project, it fulfills all these different tasks. If we talk about ROS, then we should talk about the level of concepts in ROS. They are namely 3 levels of concepts. First one is the file system. File system is like all about the ROS software, how it is organized on your hard drive. Next level is the computation graph. Computation graph is all about the running processes of your ROS system and the communication between ROS processes. And at least we have the community. And like these 3 pillars, they are the foundation for all the higher level concepts. like navigation, mapping, perception, localization, and so on. The cool part about these level of concepts is that they are following specific conventions. And if you have understood the conventions once, it's quite easy to use ROS in your own projects. That's basically what we are trying to here to teach the people here during the ROS Summer School, these specific conventions. The most important pillar is, of course, the community, as always when you're talking about an open source project. ROS was introduced in 2009, and it is growing exponentially since that. Here you can see a picture of different contributors who are using ROS and who are contributing ROS software to the ROS community worldwide. That's also one main task of the ROS Summer School, to spread this knowledge about ROS even more around the world. If we are talking about the community, I should definitely mention the ROS website, because it's, when you are talking about open source, it's a really, really good website. You have 3 key features on the website. First one is ROS Answers. It's basically like a forum where you can ask questions if you have a problem with a specific ROS software, or if you're just thinking about a new approach for a robotic application. So yeah, there you can just ask everybody who's also using ROS, and maybe there's someone around the world who has quite a good experience in your specific task and who can help you with your first steps. The next one is the ROS Wiki. The ROS Wiki is basically the whole documentation of ROS. And if I say the documentation, I mean over 16,000 web pages full of information about specific ROS software and many, many different tutorials that you can do on your own. The last feature is the news. In the news you can find information about new released ROS software, and also about community events like the ROS Summer School here in Germany. Or also from time to time you can find their job offers of companies who are looking for people with ROS experience. The next level is the file system, or the next levels, file system and the computation. I don't want to go too much into detail into that. So just to give you a brief overview, ROS is really a modular structured software. So that means that these kind of ROS modules, they are named packages. They are really fine-grained structured. And there are thousands of different packages available. And such a ROS module can, for example, include a hardware driver, or a specific algorithm, or a visualization tool, or a wrapper, or some kind of library. So if you're just thinking about a robot system, then you would have, for example, one ROS module to read out the camera images, and one ROS module to read out the laser images, the laser data. And you have, for example, one ROS module to combine the sensor data and to fulfill the task of localization. Then you have maybe also again one ROS module which is based on the localization data doing the path planning. And in the end, of course, one ROS module which would interface with the motor controller. So if you create a robot system based on ROS, then it's really meant to operate at a fine-grained scale, which makes it for the user very easy to get to still have the overview over a quite complex system. And this, together with the communication convention of ROS processes, just some kind of standard interface, makes it really easy to adjust or reuse these kind of ROS modules. Or what you can also do, you can just program your own ROS modules, of course. So what you don't have to do is, you don't have to reinvent the wheel each time you are creating a new robot system. So if there are drivers available for a specific hardware, then you can just download this, use it, and it's more or less plug and play. A nice other feature of ROS is if you think of a distributed system like that. You have a robot which is moving around, you have another system to control it, and a third system maybe a little bit far away to some kind of visualization. Then normally you have to integrate some kind of complex communication between. based on Ethernet or serial, for example. So you have to write your own protocols and all this. It's really time consuming. ROS has this functionality already included. So like a ROS system can run over multiple machines, including like dozens or even hundreds of different processes. Makes it really, really powerful in such a situation. The only thing you have to do is to change 2 lines in a specific file to determine the different IPs of the machines which are part of the current ROS system. It's really easy and really it's saving a lot amount of time. At last I want to include also a couple of powerful tools which are already implemented into ROS. Some examples is the 6D transformation. Of course, in robotics, everything is about transformation. The bottom left, you can see a robot, including all the different frames which are attached because of joints or because of a specific sensor position or something like that. And all the mathematics behind the forward transformation between frames or the inverse transformation is done by the tool TF. You don't have to do it on your own. Same for 3D visualization. There's also a tool available which is called ROS. You can see it at the bottom right. Basically, you can visualize any kind of data in ROS that you can think of. For example, maps, robot models, laser scan data, point cloud data, or images, also possible. Another nice feature is ROSBAC. You can use ROSBAC for logging data. It's very useful if you are planning to do some kind of offline processing of sensor data. And of course, RQT graph, also nice if you want to take a look at the system that you are currently running and you want to know which processes are running and how they are communicating with each other. Then you can go with the system tool, RQT graph. That's it so far with a little introduction into ROS. I would now like to switch to our ROS Summer School and to talk a little bit about that. So our ROS Summer School is an international event. It was introduced in 2012 the first time. It started with like 10 participants and it's growing till that. And last year we had around 60 participants out of 17 different countries worldwide. The next slide here, you can see a world map. There you can see the different countries where the participants did come from. So they are basically really coming from each continent. And what we also did this year for the first time, we did the first international export of our ROS Summer School concept to the Tshwane University in South Africa. If we are talking about our ROS Summer School, about the concept, then we have to talk about the FH rover. So it's an own designed robot from us. It's based on an Ackermann steered RC chassis, and it's including a laser scanner and quite powerful embedded system, a microcontroller including an IMU and also webcam. And we are using this robot to the participants was specifically in the different fields of navigation, locomotion and perception. What we really want to do is they should learn it by doing. So that's why we are doing a lot of tutorials and workshops where they can put their hands on the hardware and work in groups of 3 people for the whole 2 weeks. If we take a look at the content of this year's summer school, see that the first day we did a little ROS demo show and then a welcome barbecue. And after that, we directly started with the file system we talked about earlier. And then the next day, everything was about the communication in ROS. After that, we talked about hardware interfaces. So basically, how you can program a microcontroller in ROS style. That was followed by some introduction in static and dynamic transforms. The next day was about the simulation environment Gazebo, which we are using in all our projects. And we also did a little bit image processing in form of the AR tag recognition. Then in the weekend, we are always doing a trip to Paris because we are here quite near to Paris and yeah, for sightseeing, it's worth to go there for 1 day. And then the next week on Monday, we go on with our ROS stuff, so with localization and mapping. Then next day, navigation and ROS control. And after that, the next day, we are doing some industrial exhibition and also some lightning talks of the participants itself, so they can talk or they can present their current projects or what they are planning to do in the future. And then the next days are basically free hacking for the challenge, which we are currently doing. And after the challenge or the competition, of course, we do some kind of farewell barbecue. In addition, this year we also added a UAV workshop for basically showing the participants how you can assemble your UAV, how you can set it up, and how you can use a UAV together with ROS, the event. If we go a little bit more into detail, the day structure in our ROS Summer School, in the morning there's always a lecture that the participants also get some theoretical background information regarding the specific topic. And after that we start with tutorials. They are normally interrupted by the lunch break. And the tutorials, they are coached learning sessions where the participants are getting detailed handouts. And in addition, there are always a couple of tutors running around just in case the participants face any kind of problem. After that, we will go on with the workshop. And the workshop is really then that the groups should develop solutions independently. We just give them a problem which is somehow related to the day's topic, and then they should find a solution on their own based on the knowledge they acquired during the lecture and during the tutorials. I would like to show you a short video about our last ROS Summer School. Yeah, there you can see a lightning talk currently going on from a guy from Italy. It was really interesting. Last year we had also ClearPath here showing us some of their robots. And so that the participants can play a little bit around with them. There you can see our hacking area where the teams are just hacking around and try to solve the problems that we are giving them. Some impressions of the challenge. Rovers are driving around in the arena. This one is like teleoperated with an Oculus Rift and directly linked to the webcam. That was also really funny, in addition to the autonomous tasks. And our ROS Summer School is also a little bit about socializing and networking and getting into touch with people from other countries, and that always makes a lot of fun. And of course, also the trip to Paris is always a highlight. If you're coming from far away, then see the Eiffel Tower once is always really nice. There are some impressions from the last summer school. We will definitely also publish a video from. Yeah, here you can see the whole participants of the last ROS Summer School, and we will definitely also publish a video of this year's ROS Summer. So basically, I'm done now with the ROS Summer School. I would like to introduce two of your students who also participate this year. Amy Baker. So that they can give you maybe a couple of impressions about our ROS Summer School.
So the information then we wanted to get in that, learn more about ROS. ROS is an operating system helps all the modules of our project have an overview project, and we can view the different steps and easily debug our
So if start a robotics project, starting it from scratch is going to be like a huge process. It's going to take months for you to complete if you're going to have to write all the by your own. ROS puts it all together for you in packages which you can download online for this basically. And ROS just simplifies what's already simplified. That is, robotics is something which is going to make life easier, and ROS makes that even more easier for us.
projects. You have your own project.
Yeah, thank you very much. Okay, so let me minimize it again. Okay, so then I will now introduce a little bit the challenge that we will watch. And yeah, so wait. There you go. So we have like 2 tracks so that 2 teams can compete at the same time. And the challenge itself is that you have to start at a specific position and you have to drive 4 rounds on the tracks. You have 2 possibilities to drive 4 rounds. The first one is longer but easier. The second one needs some planning approach because the curve is quite sharp and the Ackermann steered robots, they cannot drive the sharp curve that easily. In addition, on the track there are multiple markers which can be detected and that will increase your score. So how are the rules? Everyone will start with 600 points, and for each second the rover is in the arena, the amount of seconds will like subtracted from the 600 points. In addition, if you identify a marker correctly, you will grant 50 points, and if you also identify the position of the marker correctly, you will get another 100 points. You can do it in different ways depending on your skills in ROS. You can do it completely teleoperated. You can also do it reactively, which doubles your score. You can do it by setting goal points. The visualization tool ROS that will triple your points, and you can also do it with a completely autonomous approach that will quadruple your points. So we'll now start the streaming of the competition. That will take like 1 minute. Afterwards, I will still be here, so feel free to ask questions using the chat functionality. I will try to answer them just regarding ROS, regarding our ROS summer school, or any kind of question regarding robotics. I will try to answer them as best as I can. So just give me 1 minute to set everything up for the streaming. We are also using for the competition streaming ROS. That's quite interesting, I think. We have placed 2 embedded systems in the other room where the competition takes place. And I will just now log into them and start the webcams. That's the first one, and also the other one. Both cameras are up and running. They are the system, so my laptop and the embedded system in the other room, they are connected over Ethernet, over a network. Now I start my the visualization tool ROS. in order to display the webcam images. Adjust it to fit it to my desktop. So here you can see the hacking area and also the arena in the arenas in the back. And here you can see one of our arenas, part of that. Yeah, so the guys, they are already cheering. Someone has, I think, fulfilled the task. I think we have to adjust a little bit the camera of the arena. The arena. So that you are able to see the whole arena. Okay, so just in case you have any kind of question, feel free to ask me right now. Yeah, in the upper image, you can see the different workplaces of the teams, always including like one rover and normal desktop PC for like a workstation for visualization. And yeah, there's also a guy running around with a big camera. And I think now we will fix a little bit the position of the camera for the arena. Yeah, that's a lot better. So unfortunately, we cannot show the whole arena because that's not in the field of view of the webcam. But at least we can show you the first arena with the short way. Now it's a little bit high. I hope the stream is still working. So, just in case you have some kind of question, feel free to ask. Otherwise, I will just go on talking. Yeah, maybe some kind of interesting information about ROS. We already talked about these ROS models and that they are available online or there are currently over 4,000 of these kind of packages, being all the hardware drivers for the common hardware and mobile robotics, and also including all the algorithms in terms of perception. That's the cool part about ROS because the community is quite huge. Yeah, there are really frequently new packages released with newer algorithms or newer approaches or for new hardware. Yeah. I think currently something is going wrong on the other track. I hope that we also get some action on our track soon. Yeah, so how does ROS 2.0 differ from ROS 1.0? Yeah, there are a couple of differences. I think the main goal is to bring ROS more into field of industrial applications. Normally, what the industry is always complaining about ROS is that there is no that it is not able to provide real-time support. And yeah, ROS 0.2 is basically to implement also real-time support into ROS itself. But still, ROS is also already quite common in a lot of companies. If you, especially in terms of startups, but there are also many bigger. There are also many bigger companies which are using ROS. For example, I know that BMW is using ROS or Bosch for their research department. So the guys are having fun. The basic aim of ROS 2.0 is really to make ROS more common in like industry. I think we have a team now who wants to drive to the arena.
So in 2 minutes they start the.
Okay.
But the other group was too. So that's yeah.
Okay.
They felt this small earthquake when we.
Yeah, at least they saw it. Yeah, so I think we will start with a run in like 2 minutes because the group before was really fast. So yeah, we had to wait till the team on the other track finished their run. You can see guys sitting there with their laptops. On the other camera that there are groups still trying to tune a little bit their algorithm. And there we go. Rover is moving. That's already a good sign. Let's see if it's, yeah, able to get the first curve. I'm not pretty sure which approach this team is using, if it's driving there completely autonomously or reactive. So a little bit help was needed. They will lose a couple of points. And as you can already see that the different teams, they are able to move around with a complete robot system and duration or in a learning period of like 2 weeks. Set it completely up and to use ROS models in localization and navigation. That's also something that we recognized during the last couple of summer schools, that the learning curve of the teams really high, and there you can see it again, coming close to the again, and yeah, we just see that the learning curve of the teams is really, and especially if the people have already kind of knowledge about ROS, then the first days they're more simple for them, but in the end teams are almost all of some kind of the same level. Yeah, and this was the first round of the rover. Let's go for the second round. Let's do 4 rounds. Now it's trying to get the sharp curve. Yeah. Look. Are there any other questions related to ROS or our ROS summer school? Just feel free to. That happens. Yeah, this is more or less. We have a question here. ROS is only compatible with Linux, and yeah, by now it's really recommended to use some kind of Ubuntu version. You have like different distributions of ROS. There are normally quite frequently new distributions. We are using currently Indigo together with Ubuntu 14.04, and yeah, I would really recommend that. I think it's possible to somehow install it on Windows, but I would not go. Yeah, Linux is really at the moment the framework. Okay, they are not moving it by hand. Also, ROS Indigo is a long-time version, the same like Ubuntu. There is already a new distribution called ROS Connect. All of the available ROS modules already refer to this ROS. At the moment, set up ROS Indigo and Ubuntu best solution. Oh, okay. Yeah. So what we are using is ROS Indigo together with Ubuntu 14.04, kind of Linux version. And but you can run this setup on different machines. For example, we are using desktop PC or laptops, Intel architecture, and we are using embedded PC on our FH robot with a ARM architecture. That's possible. So I hope that the team will be able to start their robot in order to do round. So part of that. Yeah, there it's driving again. Moving forward and backwards, like some kind of planned path. And is it able? No, it chooses the long. Yeah, unfortunately, we can live stream of real stuff, what's going on, action and task planning. But I hope that you already can get a quite good impression what some and the competition. Not really about determining who's the best team and who's the winner. It's like more or less to show the other teams what kind of approach developed and to get in a little bit discussion about what you can do better or what is good at your. Not really the word competition is not really the correct term to describe what we are doing at the end of the ROS summer school. We have a question about nodes and nodelets. Yeah, okay, so that's already quite into about ROS. Nodes are more or less the oh, you can see here the rover is not choosing the. Okay. So maybe back to the questions. Nodes are the execute. Nodes are also can be part or are mostly part of these ROS models. And you can program nodes in C++, for example, or also Java. So ROS is supporting different high-level languages. And Nodelets is like a specific version of nodes. The communication in ROS peer-to-peer network, and if you have and this is quite a lot of computing power. You are transferring a huge amount of data, for example, transferring image data between two nodes. And if you don't want to use the standard interface of ROS peer-to-peer network, then you can program nodelets that needs less computing. You have a specific communication between, should not be present in the whole, just between these two nodes, and program nodelets. Another question, can we use IR sensors instead of lasers? We have also an infrared range sensor attached to the rovers. Of course, you can do something like that, but then you have to take care about the uncertainty of such an range distance sensor, especially in terms when you want to drive outside, for example, or what you also just get is one point of distance. You're using a laser scanner, then you get like a 2D cut of the environment, including all the objects. What you can do is, of course, using multiple IR sensors in order to detect some kind of obstacle in direct environment of your robot. You could, for example, attach these IR sensors to a common microcontroller and run a ROS-style program on the microcontroller. That's also something what the participants did during the ROS summer school. So to read out an IR sensor with the help of a microcontroller, broadcast the distance information to the ROS system running on the embedded system. Really easy to do, and there are also tutorials available online on the wiki page website. Benefit of using a laser scanner is, of course, that you are getting a complete 2D cut of your environment. In our case, we are using TIMs, thick TIMs, and they have a field of view of 270 degrees. Makes it really easy to use the ROS models for mapping or for laser scan based localization, also for navigation. If you have just IR sensors, in addition to the lower accuracy, you will not get that many points, and so the mapping will be quite hard to map within. But what you can do is, of course, you use it for simple obstacle avoidance, so that, for example, your robot will stop in front of a wall or drive backward or something like that. That's easy possible. I think finished 4 rounds. I'm pretty sure if there is another team afterwards, I'll just ask it once. Yeah, we started a little earlier with the competition, and so we'll just check if there is one team afterwards doing the competition again.
Team coming.
Okay, so I have got the information that there's another team coming. We just take a couple of minutes so that they can set up their rovers and the laptops. We have like 5 viewers, I think, watching me right now. Any other questions? Nice fact also about our robots is, or laser scanner, that the whole robot itself is more or less a wheel based on an RC chassis, which costs around maybe $100, and then we have a quite powerful embedded system, the Odroid X4, which is around $80, and then just a normal webcam for like $, and a flight controller, which is including a microcontroller and an IM, which is around $30. And the only part really expensive is the laser scanner. So the question to use an infrared sensor instead of a laser scanner, yeah, it would be a nice approach, but then you are getting, especially in terms of mapping and localization. There is a possibility what you can use, for example, would be an Xeon. The cool part about the X is that it is an 3D camera. It's quite low cost, and you can use like one line of the generated point fake lasers. In addition, you can use the other points of the point cloud. To create like a 3D map of your environment in order to avoid some kinds of tables or chairs which are not on the specific height of the laser scanner. So I think here we have the next team preparation. Let's see how they perform. Set up the connection to start their stuff on the road. So they really want to do the track fast. See how that went out. Oh. Any other questions? I think they are currently doing it detect the markers. Do it like it's also approach to do the track quite fast. Combine it with detecting markers in order to get a lot of points. But still, if you're doing it autonomously, multiply your score by a lot, and so you should get or you should earn more. I'm not sure about that. So I got another question. Can we Lisp in ROS? I'm not sure about that. Maybe I will just ask. Okay, so I just got the information that there is a support for Lisp, but it's not that great like Python or C++. There any more questions? Because I think I'm already far over the time limit. I don't know if there are any kind of other events planned for today. They are using OpenCV for detecting the mark. So there is a ROS module available with which you can detect these kind of landmarks. You can see them in the image below. And the cool part about this is that you can detect the landmarks with one webcam, and you can calculate the position of the landmark, 60 position of the landmarks, just based on the webcam images. And internal, this ROS module is using OpenCV. Of course, you can use it for any kind of image processing. What you want to program related to ROS.
Robots are awesome. It's really cool to play around with it. So I think the participants, they really enjoy, and even playing around with the RC cars. It's good fun. So I think I say already goodbye and hope to see you then soon. Yeah, at your place, more or less. Ciao. And Heiko, I think he will as well. Yeah, switch off the link in a couple of minutes. It depends. So.
Yeah, so it seems like the team is now doing it with a reactive or a planned approach, working a little bit better than with the joystick. Yeah, so I really hope that you got a good impression of our we are doing here and why we are doing it. Also including the competition, and to see once our hacking area and also the arena itself. Because if there are no further questions, I would now shut down the stream, because I have also to start to organize some stuff regarding the following Farewell Barbecue. So if that is okay for everybody, if there are no further questions, then I would stop the stream. Maybe Nish, if you just can give me a feedback, that would be good. Okay, so okay, I got the information that you have no further question. Then, yeah, a big thank you also from my side. It was really a pleasure to do this kind of exciting events. Yeah, that was the first time for us that we did something like that, live streaming, especially to viewers which are thousands and thousands kilometers far away, and it's really in the spirit of the whole ROS summer school what we are doing here, to spread the ROS knowledge around the world, and so that the community can grow, and that they can use great benefits of ROS in their specific applications regarding the field of mobile robotics. Yeah, so that's really nice. Thank you. I just got the information that you loved the session. And yeah, I just can say that it was really a pleasure. So, and yeah, I hope soon I can see you then maybe there. So, goodbye.